For decades, astronomers believed interstellar objects like Oumuamua and Borisov would be rare, fleeting, never larger than a small mountain. But in the early hours of July 2025, everything changed. A new object, one tracking the same path as 3I/Atlas, appeared on deep space scans, and it was at least 100 times larger than any expert dared predict. Overnight, the global scientific community scrambled to retask telescopes and verify what seemed impossible. Something unprecedented was entering our solar system. If this colossal visitor truly exists, it could rewrite everything we know about cosmic wanderers and raise chilling questions about what else might be out there. What exactly is aiming itself at 3I/Atlas, and how did we miss it until now? Interstellar objects, true wanderers from beyond our solar system, have always been rare finds. Before 2025, only two had ever been confirmed. The first, Oumuamua, slipped through in 2017. It measured just 1/10 of a kilometer across, shaped more like a cosmic splinter than a typical asteroid. Its speed and strange motion sparked debate, but its size kept it on the margins of our telescopic reach. 2 years later, Borisov arrived. Unlike Oumuamua, Borisov was unmistakably a comet, trailing gas and dust as it raced past the sun. Its nucleus spanned about a kilometer, 10 times larger than its predecessor, but still tiny next to the giants of our own backyard. Each of these objects came and went in silence, their brief visits captured in a handful of images and spectra. Astronomers calculated that thousands of similar bodies might pass through the solar system each year, unseen and unremarked, lost against the glare of the Milky Way, or simply too faint to catch. The ones we did spot set the scale: 100 meters, a kilometer, never more. The odds of catching anything larger seemed remote, almost impossible. Then, in July 2025, 3I/Atlas entered the record books as the third confirmed interstellar visitor. Detected by the Atlas telescope in Chile, its path traced a hyperbolic arc, proof it hailed from another star. Early estimates put its size somewhere between Borisov and the largest comets known, but nothing suggested a leap in scale. The scientific community welcomed it as another rare data point, a chance to test theories about planetary system formation and the violent processes that hurl debris across the galaxy. These three objects, Oumuamua, Borisov, Atlas, became benchmarks for what interstellar visitors could be. Each one, a solitary traveler, small by cosmic standards, yet carrying secrets from distant worlds. Until now, their modest sizes shaped every expectation about what might wander in from the dark between stars. The instant the size data landed, the astronomical world snapped into action. Slack channels for the Atlas and ZTF teams lit up with urgent messages: magnitude curves, nucleus estimates, raw pixel counts. The first numbers were staggering. Models pointed to a nucleus not just 1 or 2 kilometers across, but possibly 10, maybe even more. That's a body bigger than some main belt asteroids, a mass tipping toward 33 billion tons. The phrase 100 times larger than expected started echoing through peer review threads and emergency call logs. Within 20 minutes, the Minor Planet Center's alert bounced across the VO event network. Observatory directors in Hawaii, Chile, and the Canary Islands cleared their night schedules. Hubble's director's discretionary time queue filled with requests, each flagged urgent, unprecedented scale. The James Webb team debated a rapid repoint, knowing every hour meant new data or lost opportunity. Even the European Southern Observatory's VLT scrambled to swap targets, pushing aside scheduled supernovae for a shot at the interstellar giant. Robotic survey telescopes like Pan-STARRS and ZTF repointed within minutes, but the big guns, Hubble, JWST, VLT, needed hours to reroute. The tension built as teams waited for command uploads and orbit confirmations. Meanwhile, amateur astronomers, armed with backyard rigs and Discord servers, joined the chase. Sam Dean, a veteran skywatcher, posted brightness updates in real time, his data quickly feeding into the professional pipeline. Every instrument on Earth and in orbit was now aimed at the same patch of sky. The technical hurdles were immediate, separating the glare of the coma from the true nucleus, tracking a fast-moving target slicing through dense star fields, and parsing raw brightness into hard numbers. As the first high-resolution images arrived, the scale shock only deepened. This was no ordinary comet. The race to understand it had begun, and no one wanted to miss the next surprise. Numbers alone can break a story, or, just as easily, expose its cracks. While rumors about a shadow object trailed the discovery of 3I/Atlas, the hard truth lives in the orbital data. Every major survey, from Pan-STARRS to the Zwicky Transient Facility, has combed the sky for evidence of a second massive body moving in lockstep with Atlas. The results? Nothing. No bright echo, no faint co-traveler, not even a suspicious blip near the predicted track. Monte Carlo simulations, the workhorse of orbital dynamics, ran thousands of possible scenarios. Each one started from the measured elements, perihelion, at 1.35 astronomical units, a staggering eccentricity over 6, inclination just past 175 degrees. These simulations tested every plausible formation, fragments, primordial binaries, even the wildest chance alignments. For any companion to stay close over millions of years, the numbers demand an almost impossible coincidence. Velocity differences less than a meter per second, separations tighter than a city block, all preserved across interstellar distances. The odds? Less than 1 in a billion. Audit reports from the Minor Planet Center and the IAU leave little room for doubt. Viral claims about a 100 times larger object rely on speculative YouTube videos and social media threads, not on peer-reviewed evidence or official observatory logs. The real sky is less forgiving. Deep imaging down to magnitude 21 shows only the solitary path of 3I/Atlas, its orbit traced with precision out to 6 decimal places. No deviations, no unexplained accelerations, no photometric anomalies to hint at a hidden giant. Formation theories still spark debate. Was Atlas once part of a binary or the survivor of a cosmic collision? But the audit's verdict is clear. Every credible simulation and survey points to a single, unaccompanied traveler. In the end, the numbers draw a hard line between what we want to believe and what the universe actually delivers. Even with every survey telescope on high alert, the limits of current technology are impossible to ignore. The Vera C. Rubin Observatory, designed to scan the entire sky every few nights, won't see first light until late 2026. Until then, the gaps remain. Objects the size of small moons could still slip through the digital net, lost in the glare of the Milky Way, or hidden by the crowded star fields near the galactic center. Each new detection pushes the boundaries, but also exposes how much escapes notice. The discovery of 3I/Atlas has already triggered a wave of proposals for next-generation surveys. Engineers are drafting blueprints for all-sky infrared satellites, aiming to catch the coldest, darkest wanderers. Astronomers talk openly about a dedicated interstellar interceptor, a spacecraft ready to launch on short notice, capable of chasing down the next visitor before it vanishes into deep space. Concepts like ESA's Comet Child Interceptor or NASA's proposed ISO Chaser are no longer science fiction. They're line items in agency budgets, spurred by the realization that the biggest stories may still be waiting just out of reach. For many, the cultural impact lingers long after the data is archived. The sense of awe, the humility in the face of something so old and vast, has bled into art, literature, and late-night radio. Some see a cosmic message in every anomaly. Others find comfort in the randomness. But the question persists. If a body 100 times larger than expected can appear without warning, what else is out there? Each answer breeds a dozen new mysteries. The next great discovery could come tomorrow, or not for 1,000 years. Until then, every patch of sky holds the possibility of a new arrival, a silent messenger from beyond, carrying secrets we're only beginning to imagine. Only 3 interstellar objects have ever been confirmed: Oumuamua at 100 meters, Borisov at 1 kilometer, and now 3I/Atlas, joined by a new object estimated at up to tens of kilometers across. Within minutes of detection, telescopes worldwide were retasked, producing high-resolution images and orbital data. Audits confirmed the object's eccentricity exceeds 6, matching a true interstellar origin and debunking viral claims of artificiality. Yet, the relationship between this massive body and 3I/Atlas remains unexplained, whether fragment, companion, or rare coincidence. Proposals for rapid response missions and upgraded sky surveys are now under review, driven by the limits exposed in this event. As of today, the object's true nature remains unknown, its course and size posing fresh questions for planetary science. The facts are clear. Our ability to detect and understand these cosmic visitors is still in its infancy. The story of the object aiming at 3I/Atlas stands as both a breakthrough and a challenge, evidence that the universe holds more surprises than we can yet imagine.